Good morning, my name is Srinivas Govada. I am working as an assistant professor in IARE college. Today, in this topic, we will discuss about DBMS concurrency control. Okay, what is the concurrency control? Okay, in multi-programming environment where multiple transactions can be executed simultaneously, it is highly important to control the occurrence of the transactions. We have concurrency control protocols to ensure atomicity, isolation, and serializability of concurrent transactions. Concurrency control protocols can be broadly divided into two categories. Okay, one is log-based protocol, the other is time-based protocol. Now, let us start with the log-based protocol. The database systems equipped with log-based protocols use a mechanism by which any transaction cannot read or write data until it acquires appropriate lock on it. Okay, it cannot start transaction unless it has access to it. So if you want to write, you have to get the right lock on that object. Till that time, your transaction will not start. Okay, locks are two types. One is binary lock. A lock on a data items can be in two states, either it is locked or unlocked. Next, we have shared or exclusive lock. This type of locking mechanism differentiates the locks based on their use. If a lock is acquired on data item to perform a write operation, then it is exclusive lock, allowing more than one transaction to write on the same data would lead the database into inconsistent state. The read lock or shared because no data value is being changed. Okay, this is when you are trying to write, then it is an exclusive lock. When you are trying to read, it is a shared lock because you are not writing anything, only you are reading from the existing value. Okay, these are two locks. Okay, now we have four types of lock protocols available. One is simplistic lock protocol. Simplistic lock-based protocols allow transactions to obtain a lock on every object before a write operation is performed. So, before you write anything, you obtain lock. That is simplistic lock protocol. The transaction may unlock the data item after completing the write operation. Once you complete your writing, then you will release the lock. That is unlock the data item. Next, pre-claiming lock protocol. Pre-claiming lock protocols will evaluate their operations and create a list of data items on which they need locks. Before initiating an execution, the transaction requests the system for all the locks that it needs beforehand. Suppose you want to have on 4 objects, you want to write into 4 objects. So your transaction will ask the system that I need lock on all these 4 objects. If all the locks are granted, the transaction executes and releases all the locks and the operation are over. If the locks are not granted, the transaction rollbacks and waits until the locks are granted. The lock acquisition phase is like your transaction begins, transaction ends. It goes on this time interval. See here, your transaction will start like this. That way, all the locks. After you have finished, you'll end it. You'll end the transaction. Okay, this is lock acquisition phase. Okay. Next, we have seen simplistic lock protocol. Next, the pre-claiming lock protocol. Now, let us see the third thing is two-phase locking, 2PL. This locking protocol divides the execution phase of a transaction into 3 parts. In the first part, the transaction starts executing. It seeks permission for the locks it requires. In the first part, when you start executing, it seeks permission for the locks it requires. The second part is where the transaction acquires all the locks. As soon as the transaction releases its first lock, the third phase starts. In this phase, the transaction cannot demand any new locks. It only releases the acquired locks. So first it seeks the logs it requires. The second part it acquires all the logs. As soon as it releases the first log, the third phase starts in its process. It cannot demand any new logs. It can only release the acquired logs. So here the log your transaction will begin like this, and it take process here. Or when it starts slowly after the transactions are over, it will start releasing your transactions, the logs. A two-phase log has two phases. One is growing, where it grows like this, where all the logs are being acquired by the transaction, and the second phase is shrinking, where all the logs are being released. To claim an exclusive write log, the transaction must acquire the shared read log and then upgrade to exclusive log. So directly in this phase, it cannot have the exclusive log. First, it has to shade the read log, and then later upgrade it to the exclusive log for writing the data. Okay. The fourth is strict two-phase locking. The first phase of strict 2PL is same as 2PL. Second, two-phase locking. After acquiring all the logs in the first phase, the transaction continues to execute normally. But in contrast to two-phase lock, strict two-phase lock does not release a lock after using it. Strict 2PL holds all the locks until the commit point and release all the lock items. So only after committing, the entire locks are removed or are released. See, first it takes the locks into it acquires, then it starts processing. Only after committing the data, it will release all the locks at a time. Strict two-phase lock does not have a cascading abort as 2IPL does. Now, this is all till now we have seen the log-based protocols. Now let us see the time-based protocols. Time-based protocols. The most common used concurrency protocol is the timestamp-based protocol. Okay, this is the most commonly used is time-based protocol. Let us see what it is. This protocol either uses system time or logical counter as a timestamp. So this is all based upon timestamps. Log-based protocol manages the order between the conflicting pairs among transactions at the time of execution, whereas timestamp based protocols start working as soon as a transaction is created. Every transaction has a timestamp associated. So whenever you start a transaction, it has a definite timestamp. Okay, every transaction has a timestamp associated with it, and the ordering is determined by the age of the transaction. Here, this is important. The ordering is determined by the age of the transactions. A transaction started at 2 o'clock would be older than all the transactions that comes after it. For example, any transaction Y entering the system at 4 o'clock is at 4 or 4 seconds is 2 seconds or younger, and the priority would be given to the older one. Suppose you have two transactions, one at 2 o'clock, one at 4 o'clock. Your 2 o'clock has a higher priority than as it is older than the 4 o'clock one as it is younger. In addition, every data item is given the latest read and write timestamp. Any data is given the latest read and write timestamp. This let the system know when the last read and write operation was performed on the data item. Okay. Now we'll see the timestamp protocol in detail. The timestamp ordering protocol ensures serializability among the transactions in their conflicting read and write operations. The timestamp ordering protocol ensures serializability among transactions in their conflicting reads and write operations. This is the responsibility of the protocol system. The conflicting pair of tasks should be executed according to the timestamp value of the transactions. Okay. So everything is based upon the timestamps. Okay. Suppose you have a transaction called T1. Okay. So it will be TS of T1. TS of T1 is the timestamp of transaction T1. Okay. Now you want to read. So the read timestamp of the data item X is denoted by the R timestamp. R timestamp is nothing but read. Similarly, for writing we have W T stamp X. Okay. Now we will see how the protocol will work. Okay. If timestamp of T1 is what? Transaction T1 timestamp is less than the write timestamp for writing of X, then the operation is rejected. Okay. If the T1 timestamp is less than the write timestamp, it is rejected. If the TS timestamp of T1 is greater than the write timestamp, then your operation is executed. All the data items systems are updated. This is the first thing about read. Now let us see about write. If transaction T1 issues a write operation, here timestamp of T1 less than the read timestamp, it is rejected. Okay. Also, if TS timestamp of T1 less than W write timestamp of X, then operation is rejected and T1 is rolled back. Otherwise, if this condition does not match, your operation is succeeded, transaction is proceeding. Now, we have one rule, that is Thom's write rule. Okay, this rule states that if timestamp of T1 is less than the write timestamp of X, then the operation is rejected and T1 is rolled back. Timestamp ordering rules can be modified to make the schedule serializable. Instead of making T1 roll back, the write operation itself is ignored. Okay, this is the concurrency controls in SQL Server.
Like, share and subscribe. Hit the bell icon for more updates.